Good morning, children. A hearty welcome to all the students of Standard 7 for the last chapter of this textbook, that is part 1. The chapter is congruence of triangles. So we learned different properties of triangles. We understood what are angles and how to add and subtract the angles of the triangles. Everything we have learned till now. So now we are into the chapter congruence of triangles. And what could be this congruence of triangles as a different name? Is it congruence? We have learned equal angles, opposite angles, corresponding angles, and what equilateral triangles, isosceles triangles. What is this congruence of triangles? Here, when we talk about congruence of triangles, okay, let us learn what is this congruence. A variety of congruence. And if you take two objects, let us take two biscuits. All of you like biscuits, right? In one packet, a 500 packet of biscuit, how many biscuits will be there for you? Maybe we can imagine 10 biscuits, isn't it? And this 10 biscuits, all the biscuits will be arranged one below the other, isn't it? One below. That is, they have same size. Isn't it? Same length, same breadth, same thickness. Everything will be same. That means to say all these biscuits are congruent. All the biscuits are congruent. Am I able to make you understand? Of course. Or take two pieces of paper or all the papers of your one exercise. Isn't it? All the papers of your exercise are of same size, same thickness and same breadth. Of course, yes, isn't it? That means the book is congruent. Now we would have got a small idea what is congruent. That means two objects of same thickness, same length and same breadth, then the two objects will be called as congruent to each other. Now when it comes to maths, we have two line segments. Let us take two line segments. AB, CD. Okay, if you have to take a scale and type by here, we can do by observation. Say, I put in the same space. Here we will say AB is equal to CD. Line segment AB is equal to line segment CD. Now, when these two are equal, obviously these two are congruent. Yes, when two line segments are equal, they are congruent. And now here if you see EF, is CD equal to EF? Is line segment CD equal to EF? By observation itself, we can say these two are not equal. The length varies. Here in the line segment, we only consider the length. If the length of the two line segments are equal, then the two line segments are congruent. So we write the statement as if the length of two line segments are equal, okay, then the two line segments are congruent. Okay, then the two line segments congruent. And here we do not congruent like this. AB, CD, we write an equal to sign and a design like this. Okay? An equal sign and a design on the about that is called as congruent. This is equal and this is congruent. If two line segments are, the length of the two line segments are equal, then the two line segments are congruent. On the other hand, if two line segments are congruent, then the length of them is equal. Is it clear? If the two line segments are congruent, then the two line segments are equal. Okay? Yes. Now, let us see congruence in angles. Congruence in angles. Now, let us take two angles like this. Angle ABC, 60 degree. Okay, DEF, angle DEF is 60 degree. So now look at this figure, angle ABC and angle DCE, both are 60 degrees. Therefore, angle ABC is equal to angle DCE. I'm sorry, DEF, right? DEF. These two angles are equal. When two angles are equal, then they are obviously congruent because they have same size, isn't it? Why they are congruent? Here, if you see, check the line segments. Line segment AB will be equal to line segment DE. Isn't it? These two lines AB and lines DE is equal in this angle. Here again, line BC will be equal to EF. Okay, these two will be equal. AB is equal to DE, BC is equal to EF. See in this line, and angle B is equal to angle E. Therefore, angle ABC is congruent to angle DEF. Okay? Is it clear? Hence, if two angles are equal, then the two angles are said to be congruent. If two angles are said to be congruent, then the two angles are equal. The next, after looking at what is the congruency of two line segments and also what is the true congruency of two angles, now let us go into the chapter as to see what is the congruency of the triangles. Here, let us take two triangles like this. Are they equal in their height and the size? Let us try to make these two triangles overlap each other. But I cannot overlap on the board. Okay? If these two triangles, that is a triangle ABC and triangle PQR, if you try to overlap each other, try to keep one triangle on each other, if they match, that means if they have to match, how they have to match? They have to match in the sense, line segment AB should be equal to line segment PQ, line segment BC should be equal to line segment QR, and line segment AC equal to angle Q and angle C should be equal to angle R. Then we can say these two triangles are congruent to each other. Okay, in that case, if all statements are true, if AB is equal to PQ, AC is equal to PR, BC is equal to QR, and these three angles inside are equal to this. A angle is equal to B angle, B angle is equal to Q angle, and C angle is equal to R angle. Then we will say triangle ABC is congruent to triangle PQR. Is it clear? Two triangles are said to be equal if they are congruent. Okay? Two triangles are said to be congruent if the length of the sides or the length of the line segments of the triangle are equal. Length of the line segments of the triangle are equal, then the two triangles are said to be congruent. Is it clear? Yes. Now, let us look into our exercise, that is exercise 7.1. By then, we can understand what is the congruency of the two triangles. Now, look at the exercise 7.1. First one is complete the sentence. So here I'll complete the statements. It's given. Let me write the statements itself. Okay. What is the first statement? Tells us two line segments are congruent. Two line segments are congruent if the length of the line segments are equal. The two line segments are equal. Okay, they are equal, then they are congruent. So this is the underline part. Okay, B1. Among two congruent angles, one has measure of 70 degree. The measure of the other angle is obviously it is 70 degree. If they are congruent, it's obviously it is equal to 70 degree itself. And look at the third one. When we write angle A is equal to angle B, we mean angle A is equal to angle B means angle A is congruent to angle B. Okay, this is the dash. Here angle A is equal to B means angle A is congruent to angle B. Now, second question, this one I would like to give it as an homework for you. The second question says, give any two real life examples for congruent shapes. Any two examples. Think of yourself like how I gave an example of a biscuit and a book. Okay, like that, take two examples for yourself and try to write the answer. Okay, now we go to the third one. Now look at the third question here for us. Here it says, if triangle ABC is congruent to triangle FED, understand the correspondence ABC to FED. Write all the corresponding congruent parts of the triangle. So here let us take the triangle ABC. congruent to, let me congruency like this, congruent to triangle FED. It is congruent to FED. So let us take two triangles. If these two are congruent, then obviously we will get the corresponding angles, isn't it? So corresponding sides and corresponding angles has to be found in this. Here we will get corresponding sides. Corresponding sides are A is corresponding to now BC will be corresponding to ED. Okay. Now AC will be corresponding to FD. Okay. The three corresponding sides we will get. The next one is corresponding angles. In corresponding angles, we get angle A is corresponding to angle F, angle B is corresponding to angle E, and angle C is corresponding to angle D. Okay, and we will get corresponding vertices. Corresponding vertices is A corresponding to F, B corresponding to E, and C corresponding to D. So what are the congruent parts that you need? In the congruence part you will get corresponding sides. AB segment, BC segment and AC segment are corresponding to FE, ED and FD, and corresponding angles you will have. The angle A is equal to angle F, angle B is equal to angle E, and angle C is equal to angle D. And we have corresponding vertices A equal to F, B equal to E, and C equal to D. For your fine clarification, let us draw the two corresponding triangles, congruent triangles. We have F, E and D. Okay, and we can say this is the vertices, and we have angles, and we have line segments. Okay, yes. Now let us look into the last one, that is the fourth one of your exercise 7.1. Now the fourth one says, if triangle ADEF is congruent to angle BCA, write the parts of triangle BCA corresponding to. Okay, now as the figure in your textbook we have given, based on that let us draw a triangle here, that is the right angle triangle. Okay. Here we will write as T, E, F, and we will come across B, C, A. Okay, T, E, F. So we have B, C, A. Sorry, we have C here and A here. So here we say this will come in the opposite direction of your congruency. Okay. Now they are asking us what would be angle E. Where is angle E? What would be angle E? Angle E is nothing but angle A. Angle A. This is correspondent. Okay. Second one, line segment EF. line segment EF, where is EF? This is EF. Line segment EF is equal to line segment BA. Okay. The third one, angle F. Angle F is correspondent to angle B. Okay. The last one, fourth one, line segment DF. Line segment DF, this DF is congruent to here. So here it is congruent to CB. Okay, line segment DF is congruent to line segment BC. So by this we finish our congruency of triangles, that is in first session, that is exercise 7.1. In the next section we will see the criteria of congruence of triangles and the examples based on those triangles, and also we will solve the exercise. Is it clear? Okay. Children, have a nice day, children.